Okay, welcome guys to the stream. Let me to check, is everything fine? Okay, internet speed is good. The audio, I think you can hear me clearly, right? Do you need a microphone? Should I get a microphone? Yes, I need a microphone. Where's my microphone? Yeah, we have a microphone. It is wired. So today, our topic is to implement YOLO paper. Okay. It is object detection, and it is 10 years ago. Like, the paper was published 10 years ago, and we are doing this old job. But it is interesting. It's still interesting to implement as a YOLO because it gives you really good sense of how YOLO was really innovative at that time compared to fast RNN or RCNN architectures. Okay, it's messy here. Actually, I was doing implementation before the stream. I already make a GitHub and make some progress, but I stuck in implementing the loss function because the paper doesn't explain in details about real implementation of the loss function. So here we need to add some more creativity and solve this small problem. I would say it's not big problem, it's just small problem which we need to fix. Just thinking more carefully and thinking more carefully. It is morning, it is 10 a.m. It is 10:46 a.m. in Songnam, in Seoul, in Korea. Okay, anyway, doesn't matter for now. So here, Ras, okay, we have it. We have this one. Okay, you can see my screen, right? But I think it is really difficult for you to see my screen, right? Because the screen is really wide, right? Can you see it actually? What about if I do like this? Okay, let's see. Anyway. Okay, I have my audio is good. Okay, zero viewers. It's fine. So now, we need to go. Let's go to terminal. Okay, what is this? Okay, we are downloading something. No, we don't need this one, so we need to go back and go to YOLO. Okay, let's clear it. And okay, this is our YOLO project. I wrote code in train.py and YOLO.py. Paper is here, so paper is this one. Okay, so this is architecture, and this is our loss function. Okay, this is what we need. This is the key. Okay, 1, 2, 3, 4, 5. 5 loss functions together, and there is a lambda, theta coordinates, theta no object, and we need to apply this to our problem. Okay, so in order to run on train, okay, in order to do YOLO itself, okay, this I test my architecture, and architecture works fine. See, it's just architecture. I am giving the but it's all positive. Yeah, okay. Okay. So I'm just creating a random array of random values of similar shape to the original data, and just passing through the architecture, and it seems it's working. Yeah, it's working good. But when I go to train.py, we need dataset, but I don't have a dataset. My dataset was in another computer, so I need to use USB, my drive. So dataset was here, if I don't mistake. Yes, no? Was it here? No. It's not here. It's not here. We need to download. So download is not difficult because I include the link to download. Okay. So here, this is this. So it will download the dataset. Okay. Copy. So if we press this one, so we are downloading from this link. Okay. But output should be not downloads. It should be here. Okay. It should be here. Output is in this directory. Let's go. What? What? What is this 12 stands for? Okay. Maybe I shouldn't. Maybe I need to replace output. What's happening? Okay, it's a small problem. It's not big deal. It's not big deal. See. So it's just zip. We don't need this 12. Okay, it is index. Output should be here. Let's go. Yep. Okay, we are downloading the dataset. My internet is what's the speed? 4 megabytes. 4 megabytes per second. Okay. Let's allow this to download. But we will open new terminal at the same time. So in new terminal, let's go to fun YOLO. Okay. We are in YOLO, right? So now let's read the train again. Okay, train.py. So in the internet, when I check the internet, Ultralyx company has the implementation of this YOLO models. It is really good, it is scalable. It is really huge. They have YOLO, YOLO 3, YOLO 4, YOLO 5, YOLO 8. All these good models pre-trained. You need just install their library and train on your dataset. It's good. However, when it turns out, when you need to implement by yourself, not that much people implemented YOLO project actually. I mean, not that much people actually understand the inside of the architecture of YOLO. Okay, so therefore, only, how can I say, original author, this guy, Joseph Redman, implemented it and make a framework called Darknet. But it is not in Python, it is in C or C++. Second guy is Aladdin Pearson. I forgot his last name. So his name is I don't have here. Okay, it is Aladdin Pearson. Just wait, I'll Google it. Aladdin Pearson. GitHub Aladdin. Who is this? Person. So he implemented it. Okay. So we have the author implemented in C or C++, and we have this Aladdin Pearson, and we have the Ultralyx company. So we need to apply by ourselves also, guys. And it's so if we stuck, we can go and read their code. Okay. So this guy, this cool guy. Total time spent, time left. Okay, 12 minutes, right? Yeah, 12 minutes. 12 minutes is good, no problem. But do I have a memory? On Mac OS, the problem is with memory. 7797. Oh my god. Problem. Okay. Actually, he implemented it, 4 years ago. I will show you. Object detection, YOLO. Yes, 4 years ago. Okay, so you see, 4 years ago. Actually, I need to put Tmax. Tmax is very good. Really flexible, easy to use, especially if you do like this. Okay. So here, first of all, we need to. We have a virtual environment. No. Actually, we don't have virtual environment. Okay, it's fine. It's fine. If we don't have a virtual environment, it's also fine. So my code is ugly, actually. I initialized this as CB. It is coming from the paper. So in paper, I didn't explain you actually, right? So actually, a paper in briefly, right? So let me to dive into the paper. So this cool guy, he said in 2016 that he and his team created a new method to do object detection at once. Okay, so image pass through the network. In the end, we have a result. Okay, this bounding box belongs to this class, or this bounding box belongs to that class. But before, it was like two-stage. First, you pass through the CNN and you do RNN, or this kind of two-step or three-steps, two or three-step methods, but they are time-consuming and they are very difficult to train. They are they're inconvenient. So he give a new way. He said, okay, we use this kind of loss function, and we use this kind of output, and we just use similar or conventional CNN layers, and we can solve it. So he did that, and it is really fast also. So the idea is that he divides the whole image into the small grids. Grid means small rectangles. Small, we can say rectangles, or we can say small cube. No, not cube. Small cube, yeah, small cube. So S by S grid. So in our case, our S is this one. Oh my God, I think you cannot see it, right? What about now? Okay. Oh my God. I hope you can see. This is C, okay? Then let me to delete this one. How to delete this one? What? Kill window. No. It's fine. So anyway, we train. So now you can see, right? No. Okay, we have two viewers. So author gets the image and divides 7 by 7 the whole image. Okay, there are 7 images and 7 images this way. So it means overall 49 small grids images. So and then he takes these images and he passes through these images through the network. And in the end, for each grid line, we get a special matrix, special tensor, okay? So in the end, we will get 7 by 7 30 tensor output for each grid, okay? For each grid, we will get that much output, okay? And it is 30 tensors. Why it is 30 tensors? It means for one rectangle, we have 30 values output. It means we pass, so we have 49 small images. We pass through the network. In the end, we will get 49 7 by 7 30 7 by 7 30 matrix tensor value. It means for one small grid we have 30 values, like vector with 30 values, okay? In these 30 values, first 20 values is class probability. So first this 20 values is class probability, and then the remaining 10 is bounding box for two objects, okay? So we have this for one batch, for one small image we have vector of 30 values. So first 20 is class probability, because in our dataset we have only 20 classes, and remaining 10 is that it is center W, center Y, weight, height, and class and confidence score. This is 5 values for one bounding box, and we have 2 of them. That's it. I hope it makes sense, okay? I hope it makes sense. Network design. Network design is not that difficult. You need to just follow very carefully about this one, okay? So input image is 448 by 448 and colored three channels, and we pass through the convolution layer and max layer, conv layer, max layer, conv max, conv max, conv max, conv connected layers. So here they don't have, they didn't say explicitly about a dropout. Oh no, they said about dropout. They didn't say about page normalization or some kind of this normalization techniques applied to this architecture. So I didn't make a, you know, I didn't make a, I didn't add I didn't add any batch norms. YOLO. Let's see my YOLO, okay? Ah, okay, we have a batch norm, okay. Okay, this is our backbone. We have the conf layer and then max pooler and then other things. Okay, here is a bug. Here is a bug. I mean, not bug. I mean, we can replace this with S, okay? Okay, one improvement. Patch norm. Actually, it doesn't solve that one. But if we include batch normalization, it indeed increases speed, okay? It will compute more faster. Because this command is outdated. Okay, this is our architecture, okay? In the end, see. So we have convolution layers. In the end, we do the flattening. Flattening means we have this multi-dimensional thing. We just make it one-dimensional, okay? And then, so this flattening will be converted to this much values, okay? This much vector of this much length, okay? And then from this value we will get this value, okay? And then we apply the value and then dropout. So here dropout, because actually in paper they said they also include dropout, but here we don't see the dropout. So anyway, I include dropout. I don't say this architecture is final, this is the best. No. It's just the start base architecture, okay? We can improve this architecture, add some kind of layers, change maybe batch normalization to another normalization, include dropout in another place, or use some kind of new techniques. So before that, we just do this basic one, okay? I include these ones. Actually, about paddings. So they didn't say about paddings also, okay? If you ignore all paddings in 2025, it turns out that the shape of matrix which they are saying will not match, actually. So in order to match, you need to add paddings. So I just guessed. I make a guessing and just include padding of number 1. And this value is actually useless. Oh. So we write and save, okay. Always it is good idea to do small atomic improvement and do a git push, git commit, okay? Git add YOLO. Git commit m. So what we did now, okay, now we did is that fix remove outdated commands and remove extra layers in YOLO.py. Okay, so we make a commit now, and now let's do a push. Okay, we did the push, done. Okay, now it's done. Like, it's good. Doing push is not necessarily good to do it all times because it takes some time, but I usually forget so to do push, so I just do all times each time. So that's about architecture. So now let's see about dataset. Dataset. Okay, 1 minute left. Okay, 1 minute left, guys. Let's be patient. Be patient. So this is our dataset. This is boring things. Okay, this is interesting. This get item is interesting. It is always interesting to know this one, because it's really important how you make this get item function, this method, because if your get item is expensive to do, then it turns out that your training, overall training, will be like, it will take more time. So you need to think more carefully, and you need to really think what you are including to the get item. Okay, it is a really bad idea to do reading from the memory. I think reading from the memory and writing to the memory, because usually when you do get item, you do it how, you do it with multiple workers, right? So when you do this input output IO, we call it IO, many times, it will actually reduce or make your training lower. And when you do it, you need to be very careful about your hardware also. Okay, if your hardware is HDD, it may be also slow. Okay, so here, if you have good understanding of computer science, general programming, then you will like really appreciate and think really carefully twice before writing a single line of code. Okay, so here we read image. I could read image to the RAM in doing init here, but I said no, because each image is independent memory inside the computer, inside of my folder. So if one worker will read one image, another worker will not touch this image. Another worker will go to another image, because there is no duplication in my dataset. I think so. I didn't check it, but I think it's like that. Okay, so here we read image and then we check the shape. So it does matter, and then we resize. So original image is not 448 to 148. It is the original image shape is different. So we need to do resize, because if we don't do resize, the output of this the output of 77128 will change. It will change based on the shape of the image which it will input to the network. Okay, and we divide and we normalize. This is normalization. And when we convert to the torch tensor, so this is numpy. Okay, and then we convert to torch, and then we do a permute. Permute means we have how can I say, we have dimensions, right? Width, height, and channels, right? So usually it comes like first height and then width and then channels. So what we need to do is that replace. So it's 0, it is 1, maybe 2, 1, 0. Okay, let's see. It's fine. So here we need to do a permute. Okay. 2 means the originally it's channel should come first, and then 0. So in image it is usually this is height and this is width. So it means height is coming first, and then width, and then so channels, height, width here. It doesn't matter, but it's good to follow best practices. It's good to follow best practices in this academia, in this industry. So then we do a boxes, labels. So I do read labels in the init. Okay, in init I have labels. I open each label as file, and then I read the lines, and I can take the boxes, class label, x, y, width, height, normalize it, and I will take this and save to the labels. Because the text itself is really small compared to image, okay? Text, maybe it is 5 kilobyte, 1 kilobyte, 10 kilobytes of storage. So if you do like 1 million of them, it will be some kind of some kind of megabytes, some kind of megabyte value. So saving the labels to the RAM is not expensive. So I just said, let's go to that, let's do it. Then I make a normalization according to the paper. So here, okay, here. So here's a small trick. So I have a boxes, right? I have a boxes. For each box we have its values, okay? 1 means x value, okay? 2 means y value. 3 means width. 4 means height. 0 means class. So it's here, okay? So we are saving this as boxes, okay? And now we are retrieving from the boxes. So here we normalize x center based on grid, based on this grid. So this grid is, so let's make a small calculation. It's 448, okay, 448 size, and we have 7 of them. So 448 pixels and 7 cubes, okay? So it means 448 divided by 7 means what? It means 64. It means this is 64 by 64. And now, for example, if we have a dog, right? And this x center means the center of the dog, and it goes to, let's say, here, right? Let me zoom in. So the center is here, right? Let's assume center is here, and then we will say it will be not 64. It will not be 100 pixels. It will be what? The origin is here, okay? Origin is here. Origin is just inside the grid. So we do normalization based on this grid. If you say why we need that, it's because it might be easier for the model to learn. Like it reduces the complexity of overall task. But actually we can change after implementation, okay? So paper says like that, so we are doing like that. I'm not creating by myself, but it is from the paper. So where it was written, okay. Each grid cell predicts, okay, we call this grid cell, okay. Grid cell predicts B bounding boxes and confidence score for these boxes. Okay. Each bounding box consists of 5 predictions. X, Y coordinates represents the center of box relative to bounds of grid cell, okay. So this X and Y is based on the grid cell, okay, not whole image. So that's critical point, okay. So therefore we take the original X center, so this is based on whole image, okay. It means this X axis, right? So our X axis is this much value, okay. It was, I don't know, like for usually let's say it's 500 pixels, because original image shape is different from before doing this one, okay. So we take this one, and because it is normalized, we unnormalize it, and then and then we multiply to 448 divided by original size. So this will give X center based on 448 size. Okay, so we convert from original, let's say from original range to 448 range, and then here we make a X with respect to grid, so that we take this X minus X IDX multiply by C grid size and then divided by C grid size. So why? So I think, do you get it? Do you get it? So here it is like we have an X center. It is unnormalized. It is just pixels in pixels. So we need to say, so like, let's say it's here, right? It's here. Can you see it? No? Oh my god, my screen it freezed. Okay, now guys, if you have problems, if there is a problem, just text it. Okay, just write on text or on chat. Okay, so here, okay, now you can see. Sorry, really sorry. So let's say if our X origin is here and this is 100, I will say eliminate the 64, first 64, and only get the remaining 40 pixels, and then take this 40 pixels and divide by 64. Done. So S grid size is 64. Let's check the dataset. Let's check if we download dataset. Oh, our dataset is done. I mean, like, we downloaded it. This one. Welcome guys. If you have questions, write in chat. I am new streamer. I may be like, you know, a little bit boring. I will learn step by step how to handle this, what can I say, this new environment and this new trend, this new thing. Okay, we are extracting the images. Do we need the original one? No, we don't need it. Delete it. Delete. I have small size. We have here. So actually we don't need this guy. Let's delete this guy. Terminate. Of course. So here this is our path, right? I'm using the path lib instead of OS. So this is, what kind of path this? Copy as path, okay? No? Just wait. Hop. Hop. So this one is for it is used for VWS, VSL. no, just wait. BSL exe in Windows. This is Mac OS. Actually, it doesn't matter, right? It doesn't matter. Why our learning is like this kind of too small. Batch size small. This batch size is fine. This is bad. This is bad implementation. This is really bad implementation. I hate this one. I saw it somewhere. People using like that. Okay, let me to get rid of this one. So it is our dataset. You need to see it, right? You need to see it. So here we have train CSV and test CSV. This is important file because here and here we have all individual paths for image and for the labels, for annotations. So images are here and they have ID 000001, 0002, and etc, etc, etc. Do you want to see images? Okay, let's see images. It's here. Okay. Oh wow, beautiful car. Good. It's like that, okay? No, I cannot move to another one. It's this kind of thing, right? Okay. And we have labels. I check the label, so class ID, X normalized, Y normalized, width, height. If you don't believe, we can check this one, okay? So I make a small calculations and then I proved that our thinking is correct. So here is it is doc. Original shape is this one, okay, guys. Shape of image is like this, original shape. But this one is 448. Okay, I have one viewer. It seems it turns out that no, I have 8 views. Okay, now it is 0. I don't have now viewers. Join, guys, join. Now important thing. Let's do the important thing. So this guy is fine. XI, X, head I, YI, width, height, object. And doing back progression is not difficult nowadays. Optimize the step fine. I cannot see it. I cannot see it. I cannot see it. I cannot see it. Where is it? Where is it? Where is it? Okay, here. Formally, we define confidence as PR object. Okay, this is a confidence. Okay, this is our score. This is what we need to do. Let me to write it. Okay. PR object. P means maybe probability. Multiply by union over intersect over union between truth and threat. Confidence score. If no object, confidence is 0. I mean, it's based on the paper. It's not my saying. Predicted box and round truth. What? Otherwise, we want the confidence score to equal the intersection over union. And what is the PR? PR means just it exists. This one means exist. Okay, now you see how I am stupid, how I cannot solve this problem. Anyway, let's do this guy. I was doing it. So we have what kind of scenarios? See. If truth is 0 and if truth is 0, and the prediction should be what? Prediction. Ya Allah. Okay, we have a truth prediction, right? Ci minus Ci. Ci minus C hat I. Oh, we have 9 views. So model actually gives us a confidence score, right? So there is a specific value for the score. So we take that score and we will, so this is that. Is that thing? Is it the confidence score? We take that one and multiply by union over intersect over union. Okay, I see. So confidence score from the model, we will receive it as it is. It doesn't matter. It will be first epochs of training just a random value. But when we are calculating the confidence score of truth, see, just wait. I will explain. So confidence, true, original, true, confidence score can be 1 if no object in this grid. If no object, then just 0. Okay, if object we use union or union intersect over union, it doesn't make sense. No, it makes sense. It makes sense because look. Sorry, it makes sense. Because each time model will predict, right? For example, model. So there is object, right? How can I see? Okay, there is object, right? And this is a prediction. If if the prediction is, so this is grid, okay? This is another grid. If they are separate, then in this grid we don't have this one, right? It's a 0. Just like, you know, no confidence score, bad confidence score. If this one is closer, confidence score will increase. So then model will think, okay, if I make it fully or like covered for 100%, then confidence score will be 1. If it is 1, I will get more reward. My loss function will be less, so that I can model will be happy, kind of, you know? Yes, we define it. We found it. So before I was doing, you know, here like I have here, where is it? Here 1. I was just assigning 1, thinking that okay, confidence just 1 because it is true original. No. See, here was my mistake. Okay, it is my mistake. So now I think we fix it. So good, awesome. So if object calculate the intersect over union, that is true confidence. Okay, now was like it was a good lesson, you know. It was a good lesson. Good lesson. I need something to drink. Now it is August. It is hot outside, so we need to drink because we are just sitting near the table and just writing a code. How can I say? It consumes a lot of our mental health, mental skills. So let's calculate the confidence score. True confidence. Okay, let's say true confidence. Okay, true confidence score is equal to what is equal to intersect over union. I wrote a function here. Intersect over union. Intersect over union. No. So here, guys, here intersect over union. It only works when we have, you know, it only works when we have an object, right? What? So we have what? We have x hat, x true. X true, y true, y true, height true, x hat, y hat, w hat, height hat. And because do we know the shape? I mean we know the image size, right? Anyway, image size and s. S is equal to s, okay. I make small changes here. Let's fix it. So here truth box comes first, and then bread b box, and we have image size, and we have one viewer. Welcome. Image size and s. Okay, you can see my screen, right? Okay, good. So here image size will be 448. We need, because b-box are normalized. What else? We need s to unnormalize x center and y center. Okay. Okay. Good. So now look. Now we don't have 5 of them, okay? We just have 4. So x center, y center, height, width equal to b box. Let me to make a function inside the function, okay? Def what we can say. So this function, I need this function because I want to convert this b box into the normal b box, okay? Wow, it's really ugly name. Sorry guys. We can fix it, okay? So here, like, let's open it. X, y, width, height equal to b box, and I want to return this one. I want x1, y1, x2, y2. Okay, make sense? So here x1 and y1 means top left side, and x2, y2 means bottom right side. That's what I prefer, and I think that's easy to find the intersect over union in that case. Let's copy this one. So we do x, and then we do past. We need to fix here. it is bad. It is bad here. It is not good. Because our x here is not unnormalized. It is normalized here, so it is small value, but we need to fix it. How can we fix it? Okay, for w is equal to, you know, w multiply by image size. Okay, h equal to h multiply by image size. Now we unnormalized the width and height, because actually they are normalized based on our 448 by 448. But how to do for x and y? So I get x. If I multiply by, you know, image size divided by s, I will get, so this is x with respect to corresponding grid size. Corresponding grid cell, okay. But we don't want that. Or maybe we need that. Let's read one more time, guys. Where is it? Guys, help to find it. Okay, here. Can you see my screen? Oh, you again, you cannot see my screen. Why? Okay, now. Yeah, now you can see my screen. Okay. Guys, write in chat, guys. If you like this one, write in chat. Support it. Oh, we have it here's bug. Size, okay. Oh, okay. Inayat Rasul. Okay. Hello. So here, do we need to unnormalize this x1, this x, based on the whole image? How I can solve this? How I can solve this one? Oh my god, just wait, guys. So let's zoom in and move here, zoom in. Okay, we cannot zoom in more. So here, look. Can you see my screen, right? Okay, good. So here we have this bounding box, let's say, okay, this bounding box, and I give this is grid cell, okay, this is grid cell, and here let's say in here we don't have any true B boxes, right? We don't have any true truth B box, but we may have a predicted B boxes, right? We may have I pass image size 448 Can I write here? Can I write here? No. It doesn't matter. No, I can do like this, you know. Open this preview. I don't care. Look guys, look. Let's solve this problem quickly. Drawings. Like this? No? Tools, text, annotate, highlight, rectangle, draw, arrow, text, mask, signature, rectangle, line, arrow, star, highlight, strike through, text. Here. Okay, got it. Good guys, good. So this is 448, okay? This is grid cell. And then we don't have any grids through B box, but we have a predicted B box, and we have image size, and we have a S. I think we should not do any kind of, you know, normalization. It is really inefficient. It's like going like making, you know, instead of touching your ear like this one, you are doing like this much work, you know, like you're overthinking, you are doing too much work. It seems like that for me, because intersect over union is always based on the object, right? It's always based on the object. For example, here we don't have image, so like here, no bounding box, no bounding box, no bounding box, no, only here, okay? Only here, and it represents for dog. And maybe this is for the bicycle. Maybe this is for car. I mean, like 1, 2, 3 bounding box. We only have that one. Hosh. We have labeled truths, and we have labeled true, right? We have labeled true, and we take this label true, and when we check for the classes, right? We are checking for classes, but if we want to check for the actual bounding box, but we should ask, do we have actually a bounding box? I mean, here we will have a problem, guys. Here during the training we may have a problem, because our label. Okay, no, we will not have a problem. Okay, it's good news, because I assign always 0 to the places where it is just 0. I mean, here it's just 0, 0, 0, 0, 0, 0, 0, all whole everything is 0. Okay, 0 0 0 0 0 0 0 0 except 1 2 3, except 1 2 3 grid size, grid cell. So we don't have a problem. We don't have a problem there. It will be values. This might be everything. Might be whole. You know, this might whole be like 0. If it is all is 0, and then it's just 0. Okay, I'm stuck. Let's take a okay, we have now complex problem. Now we are overthinking. Now we don't have a way to solve. So now let's make it the problem smaller. Okay, now we don't need to convert the box. Okay, it is overthinking. So now, oh, Korean letter. Okay, Korean letters. Do you know Korean letters? 안녕하세요. 안녕. So here, let's assume a case where our ground B box is all 0, so we need to return 0. Okay, let's do that one. Okay, if truth, so truth B box is number of it is array of 4 values, 0 0 0 0. In that case, if truth B box and it will be what? It will be torch tensor. Okay, it will be torch tensor. Okay, you need to think like 4 values for each data in the batch, for each sample in the batch. Okay, it means 1 2 3 4 and 64 of them, or 32 of them. Okay, it's like that. If ground truth in that case, how? In that case, for example, if I just do like sum, and if it is 0, return 0. This is bad. This is bad. Why it is bad? Because it works only for one sample. Okay, but we should think about batch of samples. Okay, so because first of all, this will be not an integer, it will be a tensor, and it will have a batch dimension and the representative values for each sample. So this will never work. It will never work. And if we return 0 during the training, our processor will think like, oh my god, why it's 0? We should have a like GPU moved value, or we should have efficient tensors. But here it is Python integer. It will not work. So I'm thinking that there is such a way that we can get granted, because it is just matrix multiplication, right? We can just get granted this return 0 instead of doing this summation. I truly believe. Who knows answer, guys? What if we just what if we assume that x and y in predictions and in truth, they are all unnormalized. They are all normalized. Okay. Let's one more time zoom in. Do you like dogs or cats? So for example, we have this shape, okay? We have this shape, and here we don't have anything. We don't have X, we don't have, I mean, about truth B box, we don't have any truth B box here. But we have here truth B box, okay? Truth B box. So our prediction will be here, and our ground truth is here, and our prediction always be in between here, right? So so we can kind of, you know, so our prediction is, our ground truth is here. Very ugly. Why it is ugly? Color. Permanently removed. I don't know. It's already 1 hour, guys. What is that? Bread is ready. Bread for breakfast. No, not breakfast, for lunch. Homemade bread. Welcome to my house. Come, I will give you bread, fresh bread. Actually, you know, we should not sing like that, you know. For us, we should not care about image size, actually. Really, we should not care about image size. Okay, here. We have image size divided by S, so now right? One, two. Okay, 1, 2, 1, 2, 1, 2. Actually, in Python we use, you know, in Python we use 1, 2, 3, 4. Intended. Okay, we use 4 size, but we can use also 2. It's fine. By default, it's 4 for most of the this coding programs, for coding platforms like Visual Code or etc. But you can always switch. You can always change it. Convert box. We have a truth, right? And then we have unnormalized x, unnormalized w. Okay, and height. Okay, then convert b box, right? Let me to turn off the notifications. X, Y, height. Okay. It's ground truth, right? And we have X hat, Y hat, right? W hat, H hat equal to convert box. And now bread B box. Okay. I I can know the. Okay. Oh, I have a 2.4% of drop. Okay, I know this is in pixels. This is also in pixels, but I don't know the location of this guy. Your disk is almost full. Oh my god. Okay, guys, I have a small problem. Storage. The problem is that my memory is limited. Not my memory, memory in the computer. So I need to delete something. Storage. It's better to do it here. Guys, let's have a small break. I mean, like, actually it's not break, just wait. I will delete something. Okay, I deleted 6 gigabytes of memory. Now it should be fine. It should be fine. It should be fine. Now let me to restart the capture. No. Wait. My OBS, my broadcasting computer program. Why are you not working? What? How do undo? How do undo? Okay, anyway. So here. What? I need to place that things. I need to place it somewhere. Actually, you know, I don't need anything. It's just we will assume that always it's you know, we will assume that our all images in one grid, okay, inside of one grid, inside of this one single grid. Okay, then let's this is in pixels, this is in pixels, this is in pixels, this is in pixels, this is in pixels. It doesn't matter, it doesn't matter. Oh, okay. x1 y1 x2 y2 is equal to convert bbox, convert bbox. Okay, we are professional guys. Okay, we want to be professional, we want to be good programmers. x3 y3 x4 y4 equal to convert bbox, spread bbox. Okay. So now here, imagine a space, two-dimensional space, okay, not three-dimensional, two-dimensional space, just a screen, and we have points, okay, we have 1 2 3 4 points, okay. In each point we have x and y. So now we need to find intersect, okay? In order to find intersect, what about if we do NP, not NP? So we need to find the maximum torsion max between x1, okay, no, between x2 and x3, torch max y2, y3, 1 2. Yes, but I don't know, maybe our, like, maybe I'm calling wrong API. Maybe torch.max, actually it will not return the tensor. I think it will return, you know, it will return the indexes, arguments, like index values also. So now I have max values, and then we need to find minimum between okay, wait. If we have overlap like this, we need to find this overlap rectangle, right? Okay, let me to draw. Noob lesson. One rectangle, okay? No. Second rectangle, okay? What? Okay, we have two rectangles. You know, actually we need to delete this one. We have a rectangle here, and we have another rectangle, okay? And then this is union, okay? This is union. So we need to find the maximum between this one. We need to find minimum between this one and this one, and we need to find maximum between this one and this one. It can move like this, right? It can be like this. It can be like this. It can be like this. It can be like this, right? It can be like this. It can be like this, right? So here union means, you know, this is a rectangle of our union, right? It has this one and it has this one. What if we say we need to find maximum between this one and this one, and minimum between this one and this one? YouTube is not receiving. What not receiving? Okay, guys, can you hear me? Is everything fine? Error. YouTube is not receiving what? Error is not receiving what? Okay, excellent connection. Now we have excellent connection. Okay, no. Now I fix it. Now we fixed. I think it's because of internet. Oh, guys, we have, okay, 1 viewer, second, two viewers, two. Good. That's good progress, guys. Good progress. So I think I get stuck in this one. So we need to reduce the problem into a small problem. So in order to do that, let's do the, you know, let's just make a small, let's make a small program, a small function. Can you see my screen? If by accident my screen freezes, write in chat, okay? Write in chat, I will read it and then I will fix it immediately, okay? So now I have some idea implement this intersect over union function. So let's make it implement on our small example, and then if it works, this algorithm which we implemented, then we can apply to the torch tensors, into the torch tensors, okay? So it's a very good idea. It's always good idea to split the problem into small problems and fix them, okay? Whip test intersect over union. We will work now with numpy only, numpy for numpy, okay. So here we have x, right? Here, I mean like bbox1, okay. So here, if we have a bbox1, and then it is np dot array, and then our x. It will be 10, 10, x, x1, x2. Okay, let's say I don't know what value to choose. What value to choose? 3 and 3. From 3 to 7. 8. Okay, 7 by 8. Okay, I like number 7. bbox2 equal to np dot array. Let's make it inside. Okay, we have two bbox. Okay, now def I owe you bb1, bb2, and now what I'm saying is that you intersect is equal to np dot mean between bb1 of what? 0 and bb2 0. It means x, okay? I mean, it's not intersect. It's actually, I am making a problem. I'm making you know, yeah, my approach might be not good. I know it might be expensive, my approach. So now we have x and y. Area will be what? Look. Area is means width and height multiplied, right? So now x2 enter is always higher than x1. y2 enter minus y1 enter. Advertisement. So now IOU BB1 BB2. NP is not defined. It was stupid. It was really stupid, guys. Where we have a problem. np.mean. np.mean throw exception. X is error. I mean, we should not use, you know. Three, 10, 10. Okay, it works. No. This is not union. It is. We make a mistake, guys. It's not union. This is union, right? Am I right? 5, 5, 6, 7. This is union, guys. We don't need any erasing, guys. Just need the list. 0, 0. One hundred, okay. And we have another one. 0 and 0. 10 by 10. What is the shape? What should be the result here? Okay, guys. BB1, BB2, okay. Print it. Okay, 100. Good, correct. That is correct. That is union. That is intersect. Sorry, that's intersect. Okay. First test pass, second test pass. We need to one more test. Okay. We need a trickier one. Tricky. Let's say what is if the rectangles they doesn't match. They are not intersect. Let's say 0, 0, 100, 100, 200, 200, 1000, 1000. Oh, 2000. Okay. What will be here? Here we have a problem. If we do max min, it's fine. But at the same time, we should introduce a new thing. You know, we should say if x1 inter is less than, here we should introduce, okay, if x1 inter is less than what? If this point is less than x2 inter, no, it should be not like that. It should be not like that. That one should be less than see, and y1 inter should be less or equal, okay. No, I make a mistake. If it's bigger, delete. If it is bigger, then just get rid of it. Okay. What happened? What happened? Here our problem. We have a problem. This guy doesn't work. This guy doesn't work. Good. How can we improve this algorithm? Algorithm is working. Algorithm is working. Good. So the thing is that we need to find max and then min and then compare. But in TinyGrad they did another thing. In TinyGrad. Now we need to do, Tmax, okay? What? Oh, we have a Tmax already, guys. Why you didn't tell me? Can you see it? Can you see it? Can you see? Okay. So now Vim test. Open it. Here I will open train. Okay, guys. Okay, now we have this one, right? Intersect over union, and you know, we can, you know what, we can do smart, you know, we can just test it, you know. Here we say, oh, whoop, and then we say intersect over union, and then we say import sys.exit 0. Means just exit, do nothing from the below, just exit. Okay, this is our test. We need to pass two bounding box. Okay, bb1, bb2. Now b1 is equal to what? Torch. Do we have a torch? Yes, torch tensor x, y, width, height. Okay, x, y 0.5, 0.5, 0.5, I don't know, 0.1. Let's say 0.5, 0.6, 0.7. bb2 to equal to torch dot tensor. Let's say our prediction is exactly on 0.5, but it's like this, you know, like 0.3, 0.7, let's say. I'm not sure if this is correct, guys. To prove it, let's do a Python. Okay, import torch. What? No module torch? Just wait. So conda env list. I don't want to install torch. Torch is really huge. Alpoamesh. Do you know what is alpoamesh stands for? Conda activate. Alright, checking. Okay, now I think we should have a torch. Strange. Actually, I need to have a torch. It seems my torch is broken. I mean, in IPython. So I'm saying that torch.tensor. If I give like 4 values, okay, we are getting that 4 values. Okay, good. Now we can do a test. Okay, okay. So now in IOU, right? You can see my screen, right? Okay. In this IOU, we get maximum between x1 and i2, and we get the intersect. Oh, we didn't complete this function, right? Here, for example, now we have intersect, and then intersect over union is equal to what? Intersect divided by union. union means what, you know? Union means union means we need to get area. Okay, we have a battery. Okay, in union means all area. Okay, it means BB1 2 minus BB1 0 multiplied by BB1 3 minus BB1 1. Let's take this in brackets. Do you know why we are taking in brackets? I think you are smart guys. You are all smart guys, and I'm here, you know, like trying to do something. If you know this answer, just give hints, guys. I don't need the answer, but just give hints. If you know, if you want to help. Okay, we have a B, and then we do a plus. And we need, it's the same for BB2 2 minus BB2 0 multiply BB2 3 minus BB2 1. Okay. What? Plus that one, and minus intersect equal to copy paste. And we don't need to do this one, you know, like in that case, you know, in that case our intersect should be 0, you know. This is bad. We should say intersect equal to 0. I will say cannot access local variable intersect. What? Cannot access? Let's check it. Intersect. Intersect. Okay, correct. Okay, we have a typo, guys. Typo. Okay. What? Guys, here we have a problem because we return a value, right? We return union over intersect over union, right? But we need to print also. Nobody will print for us. Nobody will do our job for us. Intersect over union. It is between 0 and 1, okay? I owe you. I owe you. Oh, very good. What? In this case, it should be 0, 0. We have a bug. I think we should include one more bracket. Oh my, I know it becomes ugly. Now we need one more example, guys. Now, you know, if we say, here, tick. Now if we say here, if I say 0, 0, 100, 100, it should be, it should be 1, okay? Assert. And if I say 50, 50, 100, it should be 0.5, okay? Make sense? Make sense? I agree. It's saying 0.25. 0.25 instead of 0.5? Really? No, no, no, it should be 0.5. Because our area is 0.5. If we don't fix this problem, we cannot train a model, It's tough. 0.5, 0.25. Okay. I need to check one idea, one thing. Tmax, delete, close a session. Okay, panes. Okay, we call it this pane. Okay, how to close a pane? Idea is simple. Look, go here. We are here, right? Yes, done. Okay. So So now. Oh my god, we have 3 viewers. Welcome, guys. Welcome. We have a union over intersect problem. Here it should be 0.5, but it is 0.25. We have a bug. We need to debug it, okay? Set over union. We need to debug. Don't we see? Huh? Обед? No, brother. We need to... Ha? Bir şey bulduk. Pişmedi mi? Titi tıkladık. Buni anavi ko'yayotgan shu to'g'ri. Qaysi? Qo'y. Ya men ishim to'g'ri. It's true. I make mistake. Ellik. Hayır. Biz streamdan xalaqit beryapsiz aka. Break now. Break time. Milk almadın da aka. Albatta ichaman. Aka bu bunaqa bo'lsa 25 bo'ladi. To'ppa-to'g'ri 25. Correct, everything is correct, guys. Correct, because look. If I say, you know, if I replace this guy with 1, oh no, insert 1, 0, it should be 0.5, and if I do like this, it should be 0.25. Good, done, fixed. Bu sizniki mi? Men ikkita solib qo'yibman. İçmedinizmi o'zi, ichmadingizmi? Men ichdim lekin aka. To'dan ichdingizmi? Ya ish o'zi ichib turdim-da. Просто idish ishga to'lgan. Qiziqmas ekan aka. Good thing is that we fix the IOU for our case. And now we need to implement it to our problem. So we have these guys, and now intersect our union. We don't need this one. So here, convert B box, right? Convert B box. Now we need to find maximum torch dot maximum, yes, and it will say x1 enter torch equal to max between x1 and x3, okay? y1 enter equal to torch dot max between what? y1 and y3 or y2? then x2. Here should be mean x2, x4, okay. y2 enter torch mean y2 y4, okay. x1 enter, it will be max, right? Okay, let's check it here, okay. What? Software update. No, we don't update, okay. It's not today. It's not your day today, okay. It's my day today. There is no update. Okay, actually in Torch, when you import Torch, okay, let's say we have a matrix torch dot rand n, or let's say 3 values, okay. We have 3 values, right? A dot torch dot max between a to give us maximum, right? But in our case, oh, it's sun. Our case, it will be what? Batch size, let's say it's 64, and we will receive 4, okay. A dot shape 464, yes, 464. And if I do torch dot max on a, values shape. Do we have viewers? No, we have 0 viewers now. 1 2 3 4 5 6 7 8 8 by 8 64. Huh? Yeah, we don't care. Like, viewers will appear later. So it turns out that when we do max, but here we are doing max between 2 arrays, right? I mean, we have two values and we are doing max, right? We have a, right? Let's make it b, okay. B equal to torch rand and 64 by 4, okay. We have b, okay. We have a and we have b, okay. Correct. And now if I say torch, we should check the documentation actually. Oh, actually x1 is, x1 will be okay, just wait. We make a mistake, guys. We make small mistake. It should be 1 like this. Yes, definitely. And my dear Richard, definitely a, okay. Torch dot max between a and b. It will work, guys. It will work. It's good. It's good. So that our function should work. So now let's check it. Huh? Let's check it. No. Let's here. We save it. Okay. Now go here. Exit is Python. We say Python. Then we say what? Train. Import sys invalid syntax. Here we should add semicolon. Indentation error. Indentation error. It is okay to have problems, guys. We should fix it. We should be always positive, okay? Class count. Class count. Are you talking about this one? Right? But you are talking about this guy. Okay, I deleted. I deleted guy. Let's do it. Let's read the problem. Okay, guys. When we call the program in line 107, we have a problem. 107. Here we call intersect over union, and then intersect over union missing 3 required positional arguments. We need 3 positional arguments, but we are passing only 2. Why you want not giving all values? Okay, b1, b2, image size equal to 448, s equal to 7, 1, 2, 4. Okay. Who adds self to here? Stupid. Guys, please check my problem. I mean, like, check if I make mistake. What? Why delay in your voice and face cam? Really? Oh, it is 11% drop frames. Oh, again, my screen is not working here. Okay, now it's actually working. Now it's working. I think now it should be fine. Oh no, why internet is so bad? Is it fine now? Is it good? Is it good now? No? Okay, we have minus values. And if you say, is it fine? Is it okay? Is it okay to have minus values? It should be okay. It should be okay, guys. It should be okay. Because we don't care about location, actual location. Tough, but good. We need this kind of challenge. So we get a maximum, minimum, and then what? It means it's working, guys. It means it is working. Yes. So we did these things, and now we need to apply this formula. We need to find intersect. Intersect equal to intersect. Biroz bir tekshirib yuboring meni iltimos aka. YouTube'da meni tekshirib yuboring. Eshitilyaptimi? YouTube'da meni eshitilyaptimi o'zi? Mana bu yerda bittasi why delay in your voice and facecam deyapti. Qotib qopti aka. Problema. Live stream. Abdirayimov. Eshitilyapti. Okay. Sobirjon Qadamboyev. Okay. Good. Aka bu tekshirmasangiz ham bo'ladi. Okay, our intersect is what? It is x2 inter minus x2 inter minus x1 inter. Qanaqa noise u? Xolodilnik emasmi shu? Yo'q, xolodilnik emas bu. Bu microwaves. Yo'q, men bu kompyuterdan aka. Hozir fix qilish kerak buni. Problema. Qarang, buni olib qo'ysak. Okay, now test. Guys, is there a noise? No? Noise. Orada necha minut gap? Orada bir 30 sekund u. Noise ketmayapti aka. Qayerdan kelyapti noise? Meni eshitilmayapti-yu. Oh guys, we have small problem. Nima qilsak bo'ladi aka? Ya bu problema kompyuterdan aka. Hozir qarang. Men hozir audio inputni boshqa narsaga o'tkazaydi. Okay, hello. Hello. Okay, hozir MacBook mikrofonda turibdi. Qaysi? Now, okay, now good. Menimcha balki meni mikrofon, anavi, special mikrofonda problema bor deyman. Yaxshi ham qaradi aka, mana qara. Hozir endi odamlarga yoqyapti. Okay, now better. Okay, good. Let's continue, but before push-ups, guys. I make mistake. Push-ups. Push-ups. We need to do push-ups. Your problem is we fix problem. Just we need to apply to torch, PyTorch stuff.
How many push-ups for Mystic? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 6, 7, 8, 9, 13.
Okay, we are ready to continue.
लेकिन खाते हैं
Hey?
जो हमारे सिस्टम का स्पॉट
What? We need Wi-Fi, brother. We need Wi-Fi. Ничто там курят только?
İşte.
Niye ko'rsatmayapti?
Bilmiyorum. Kaç dolar?
How many viewers do we have? 1 concurrent viewers.
Bu hit kasa çıkıyor. Dışarıda var mı?
Hı?
Videolar çıkıyor.
Shirinlikkami yo yomonlikkami?
Üstü yoruluk.
Ustidan nasib kerak edi narsalar.
Salına kadar yoruluk.
Okay, intersect. We need to find intersect area, okay? Continue, let's continue. Can you? Oh my god, oh my god.
Pişen.
Ha?
Pişen.
Pishin qolish kerakmi?
Yok hatta yo'qlaydim biliyorum.
Endi pishin kirdik aka.
Yarım saatten yapışarken o. Yani düşünce mesela.
Okay, we have half hour. Half an hour, right? No. Half hour. Intersect is that one, okay? And intersect over union is equal to
How zor çıkıyor?
Ha?
How zor.
thumbnail mi?
Hı?
Thumbnail.
Thumbnail değil ama how değil.
Menikimi siznikimi?
Sizniki. Live to how. Saytda bu.
Shunaqa qilgan yaxshi o'zi.
Просто шрифт.
Ne ekan?
Sen bilan oddiy.
İyi. Okay, we do minus intersect. Here we do plus. Here we need to find the first rectangle. X1, right? X no. No, X2. That's X1. X1 multiply by Y2 minus Y1. This is one rectangle. The second rectangle. Second rectangle. Oh, again, drop out, okay, drop out. Igen kurmapti men nahotki. It's saying 0.5. Is it correct? Yes, it's correct. It's correct, it's correct, yes, it's correct. It turns out that it's correct, actually. Yes, it's correct. Let's make it a batch, okay? 0.5, 0.5, 0.6, 0.7, and here it will be 0.5, 0.5, 0.3, 0.45, and then let's say it is 0.5, 0.5, 0.1, 0.1. Let's say here it will be like 0.9, 0.9, 0.1, 0.1. This is problem. This creates a problem because we need to assign not based on the first dimension, we should assign based on the second dimension. I will explain the problem, guys. Wait. Import torch. So now equal to torch and n. Look, we have 8 batch size and we have 4, okay, like this, right? Now if I say x, y, width, height equal to a, it will say error. So now instead of that we need to say maybe there should be special call, special API, I'm sure. A dot what? A dot start, A dot what? If we do a dot transpose, it works. Because if we do a transpose, it will be transposed, okay? Bunları bomba yaptın. Bruce böyle yaptı. Let's create one more example. Insert, okay? What is it? Let's say we have 0, 0, 0, 0, okay? And let's say we have, 0.1, 0.1, 0.01, 0.01. Yaman eding o'shanda. Five, 0.5, 0.6, 0.7, 0.9, 0.9, 0.0001, 0.0001. Can it work? Can it actually work? I mean, I like 448 multiplied by 0.001. 4 pixels, right? Guys, sorry. Actually, not sorry. Sorry. Actually, why I should not apologize? Because problem is always happens. We should be always ready for problem. This -1 is bad. Now we should implement it. So here, when we calculate intersect, we should calculate intersect like this only if what? Only if test what? Get rid of this. Only if x1 inter is more than x2 inter and y1 inter is more than y2 inter. Okay. Only if this satisfies, then we work. Otherwise, we should just make it 0. Okay. What? Guys, let's get out. Cannot write your info file. So here, Python, okay. Stupid. It sucks, okay? Hold it together. Guys, can you see me? Can you hear me? Okay, now it should work. Now it should work. Now it should work. Okay, let's keep continue. Let's keep going. The problem is that import. I remember. Import torch, and then. Guys, can you hear me properly? Can you hear me? Can you hear me properly? Is there any so here we have a torch, right? We have a torch and we have a torch and we have a shape of like this. Okay, see, like we have 8 by 1. Okay, we have this kind of shape. Okay, and our task here is that if, for example, if it is minus, or if it is, let's give a small condition, like if a value is minus, make it 0. Can I say like that? Like, actually, I don't need to do minus. I mean, I don't have a specific number. I need a condition where x1 inter should be less, like if it is higher than x2 inter and y1 inter is higher than x2 inter. In that case 0. Okay, 0 should be return 0. We should do like that. Torch. let's say not B, let's make it more concrete, more objective. It will say, it will be y2 inter, okay, x1, x2, x2, and we will say x1, okay. Now if I say x1 inter more than x2 inter, true, false. Let's say intersect equal to x1 inter, okay, and intersect x1 inter more than x2 inter equal to 0. Intersect. We can do like this, guys. Do you think it is efficient? I don't care about efficiency right now. Maybe not, maybe yes. So here we have intersect, right? And then I will say here, you know, intersect where x1 inter more than x2 inter and y1 inter more than y2 inter equal to 0. Can I use double this? What was that? What was this symbol? I don't know. Can I use that one? Maybe yes. Let's check it. Okay, only one. عشان معك يا بلاد فكرة لماذا قطعت بوم ها ما راكت شتنا سالوت من هنا وقت
Soxta trevога deydi nimaga? 20 kuni sevuvlik bo'lsangiz, haftaga 2 da qosh desa qoching.
Xo'lar kutib qola? Nima? Kim olib kutib qola?
Milisada.
Nimaga?
Soxta trevoga bo'ladi. 20 kuni 2dan keyin.
Guys, I think we did it. Aka bitta implementation qilib tarasan. Hali model train qilganimiz yo'q. Implementation bilasaz. Hali implementation. Do you think we have a bug? Maybe we have a bug. What? Actually, we didn't check 100%, right? Let's check it, guys. If I do like this, it will be floating points, okay? If I do like this, it will be integer. If I do like this, it will be floating points. Like I'm explicitly saying that it should be floating points. Last one should be no, like this guy should be 0.5. Yes. This guy should be also 0.5. It should be more than 0.5. Replace 3. 35, right? No, this should be also 35. This should be 25. This guy should be 25, agree? This guy, I don't know properly. If I do... Oops. Guys. Brother. Replace 3. Replace 9. Replace 9. Guys, I think it is working. It is working, guys. I have to have a small break. I need to go bathroom. Bedroom. How to disable the audio? Okay, hello. Hello, can you hear me? If there is a noise, tell me, okay? If there is a noise, like it's distracting you to watch, tell me. Tell me, guys, tell me. We have one viewer. Congratulations. You are a good guy. Let's learn. Let's make it done. Our solution is working. I will assume it's working, okay? And then return IOU. Eliminate. Is it fast? My god. We don't care. Oh no, we care about this. Page size. Fine. Good. Image shape, labels. Score true. Which one is good? Score head. Score true. Madas class again. Madas class.
پیشم بخواه کسی
پیشم خواشم سیرک. It is 1 p.m. 1:36. 1 p.m. 36. Huh? Score 2D. Unsqueeze, okay. Why doing unsqueeze? Score 2D. Class. Oh my god. Extra things. I don't need any condition. I don't need conditions. I think I make mistake here, you know, like guys. Here we have a problem. Here we need to debug this, guys. I'm not sure whether this is correct or not. So now if I do the training, okay, we have a break, okay. So now we are doing, like, we are reading from the actual data set. Okay, we have a problem. List object has no attribute Because correct, yes, because it is not a tensor. Overthink, overcomplicate things. X3 is not defined. 진짜 유하게 두개 많이 가고 사실 오늘 픽스 모습은 now it should be always 0 because the model cannot learn from first trial. Let's check the formula. Let's check the formula. Where is it? Okay. DNK에 물어보셔. 어떤 거랑 한대 무슨 준대보다. 수학 다른 얘기하면 준다. Okay, we don't need this window. Oh my god, I didn't save it. formula. So now we have loss, right? We have a total loss. Look, we have here B, right? I mean, this means wait. It's not visible. No, guys. So here you can see this B, right? And it means for each B, okay? We compute this one, this one, this one, this one. This is outside, okay? So for each B in range, okay. What is this? Xi. Where is Xi? Let me to delete this empty line. Oh, just wait. Look, MC mean square error of x and y is equal to only for object. What is this? Okay, just wait. Xi minus x2 minus x hat squared plus y2 minus x2 plus score true. I see. What I did is that if score is true, it means, object exists, okay? Don't pay attention to this one. It is in the end, after doing this whole operations, okay? It's in the end. This is really smart. This thing is really smart. If you catch this thing, you are smart. You can like you are capable. You should think like you are capable. What is this, brother? This one is fixed. This one is fixed. The third one. Ci minus. It means confidence score minus predicted confidence score squared if object exists. Okay. Same shit. Same thing. Okay, here. MCE conf score equal to plus equal object exists multiply object exists multiply C true score Is it correct, guys? Do you think is it correct? And we have MCE, no kind of score plus equal 1 minus operator is multiply by score minus score squared. Turn it off, guys. Okay, we have one viewer. Good. We will improve, Raza. We will improve. For now, one viewer is good. The last one. Okay. Last one doesn't depend on the box, right? It doesn't depend on box. It's just about the classes, right? So about box is done. Correct here. For S is here. So here we need fifth loss. Here. What is this? Complicated. I don't know. So PIC means what, you know? This is all bullshit. What? Guys, we all know that we have for each grid cell we have a 30 vector, right? Vector of 30 values, right? And first 20 is class probability. And it's like we have 20 classes and we have class probability. And now it is saying to like subtract from the true classes and use false class and take a square and make it sum. Make it sum? I think I am missing something. I am missing something. Because it's one hot, it's kind of one hot encoding, similar to one hot encoding. Okay, let me to explain it more in more details. Now we have a class control, like class control. Class control. But do you think it makes sense? Because usually in that cell maybe we have two values, three values. No. For each cell we have only two rounding box, two bounding box. If I have only two bounding box, it will be like 0,0,0,0,0,0,1 somewhere. And in class condition, it will be like probabilities, right? Probabilities like 0 something, 0 something, and we subtract between each other, and we make it squared to make the problem bigger, and we make a summation, right? It gives me a small feeling that it might be wrong. Write in comments, guys, if you, what do you think? What do you think? Is it correct? Are we doing the right thing? And what about this guy? Oh, break time, break time. Guys, nima bo'lishi mumkin? Короче, bro, we should fix this one. This one. Maybe it's just for only objects. So here we don't do for whole. This is bad. But then we do this multiplication, and then we need to give, we need to multiply. We need to multiply to class Why we are multiplying to class control? Because this is consists of 0, 0, 0 everywhere except to the class where it belongs. It will be 1. So it means when we do this first left side multiplication, this quadratic, when we make it squared, and it will be squared for all whole array, right? And if we use this class control one more time, we have a lot of zeros, right? These zeros multiplied with these guys will make a, like squeeze, like splash, that these guys will be 0 except for the class where it is actually we care about. Actually we need not non-zero value. How we will name it? Class loss. I already named here. Now, guys. Ovqat tugadimi aka? Ovqat tugadimi? Name MSE const score is not defined. MSE const. Copy. Okay. Awesome. Guys, I need to have a break. I need to have a. Oh my god. Oh my god. Oh my god. Schlechte, no bug, but we are not training. Okay, break time. Break time. Mim. Ja, mina break uur, hè? Guys, break time. I need to have lunch. Assalamu alaikum rahmatullah. Welcome, guys. Can you hear me? Okay, 0 views. Okay, 1 viewer. Okay, welcome, guys. Welcome, guys. So let's continue. I am back. So we are streaming for 4 hours already. Wow, so much time. Can you hear me? Is there any noise? No noise. If there is background noise, tell me. I turned on air conditioner. So maybe it might like give little bit noise. We implemented those function partially. We need just to train and check. The most interesting part is left. Okay.
chiqqandan har kim soqol olishi ishga chiqqandan har kim soqol tekizlash kerak.
Qayerga?
Bu yoqqa
Nimaga?
qarimmi?
O'zbekiston Moskva.
Ha?
Ha, nima qanaqasiga gaplashmaylik? After stream. Ko'cha so'ragan.
Assalomu alaykum. Alo. Assalomu alaykum. O'zingizga. Ishlayapsiz?
So 1 2 1 2. Total loss is equal to theta. Do we have theta? How well? Like yes, we have a theta. Theta chord. We have one viewer. Guy, hello. Can you hear me? Chord. Let me see. XY plus theta chord. Let me see width height plus it seems the dashboard here is incorrect, seems like. And then we need a MCE conf score plus theta no object multiply by MSE no conf what no conf score plus MCE class loss. It should be like this. Print total loss. Okay, we have one print here. Good. Guys, awesome. Oh, whoop. Okay. Yes. it will go like forever, or like infinity. And I don't know like what will be the initial loss here. Let's see. Oh my god, it's expensive. Now it's computing. Don't you believe? Do you want to see? Do you want to see explicitly? You can see right? You can see right? Okay, so memory is, what is this? Python training. It's using what? 395 gigabytes. No, it should be not like that, you know. There's some kind of bug. Okay, this is dataset, okay? This is our function. This is our epoch, right? For batch. It should be here, okay, guys? Make sense? Make sense? Make sense? Go! This is our, oh, that was our loss, okay? Okay, let's see one more time. So now we are not doing any back propagation, right? Back propagation should help us, and like back propagation plus optimizer.step should help us to reduce the this loss, okay? If it is reducing that, it means our model is learning, okay? Let's check it. Let's check these things. Optimizer, okay? Optimizer, it's 0 grad. Do you think, how can we do the loss? Total loss? This one line is done, guys. Done. It's back propagation. Actually, this back propagation should be really scary, really huge computation. But thanks to Torch, we have automatic gradient calculation. Backprop and then optimizer.step. Let's see. Tensor object has no attribute backprop. It was not backprop, it was backward, I think. Huh? It was backward, right? It's not backprop, no. So it was backward. Grade can be explicitly graded only for scalar output. Huh. It's saying that our total loss is not a scalar. It's saying that total loss should be scalar. Wait. It's for like now total loss is, it has a dimension, right? No, let's check it. Actually, it should be like, you know, like here it should be like only one number, one value. Now I eliminated, I like disabled the back propagation function. I just put the optimizer. It's tensor. We have two values. Really? Do we have like that? And what is the best way? Is it like average of them, or is it like sum of them? Average, right? So here, total loss equal to torch dot mean okay. Now it should be scalar. Now we can do, guys, finally. Let's check it. Can we do 33? 50. Oh, it's increasing. 39. 35. 67. 31. 77. It's increasing. 50, 42, 52. In paper, how long is it trained actually? In paper, do they write? Did they write about that? Did they mention about that? Oh, 1, 3, 5 epochs on training and validation dataset, Pascal, and this one when testing on 212, we also include testing dataset for training. Okay. So I have this dataset and this dataset. I think we have both of them. Through the training, we use batch size of 64. My batch size is not 64. Momentum from 0.9. Momentum. Do I have momentum? I just use Adam. A decay. I don't have a decay. I don't care about decay. I don't find this is, you know, it gives improvement, but it gives really small improvement. You know, like under the 10%, I guess. Guys, it seems it's working. So git status, git add train, git commit, git commit m. Train is write code for with full loss. This is not full, this is total loss. Git push. Go. Okay. Now vim train. Okay. So now we need to improve batch. Batch size is 2 now, right? You know, we need to make it, you know, replace 64. Add. Insert add 64. Do you think this is small? No. This is good. I like 3. Epoch number of epochs. 100. Do we have a good GPU? Unfortunately, I don't have a good GPU. And actually, I don't have any GPUs. So now we need to create an algorithm which will tell us like average speed, average speed per mini batch, average speed per epoch, and remaining time. So it is convenient for us to think, okay, if I wait this much time, I can like probably train this model for this much time. We need to implement this guy. But before, I think now it is running on my CPU instead of my MPS, instead of my Apple Silicon. So Apple Silicon is a fancy word for Apple GPUs. So Apple has in my laptop they have what M1 chip. They call it M1 chip. So this M1 chip has specific architecture. I am not that much good at hardware, but they have this GPU and CPU inside in one integrated chip. So this is chip which has processors, this transistors, and CPU and GPUs inside this chip. So they are not separated as in like gaming PCs. Okay. What? Oh, Korean. Like here, device equal to torch device MPS. Yes, right? Images equal to I don't know. Oh. Import time, okay? Import time, and then for each epoch, start epoch equal to time touch by time. What was count perform? Time dot count perform. What was the function? Count perf count. So import time dot count. No. Perf counter. Good. Batch. Guys, we have only one viewer. I think it's wrong. I think we don't have one viewer. We have 0 viewers. If someone can hear me, just type in chat, guys. Because I don't know, this OBS program, this broadcasting program looks like it's not working. Start, we have a start and finish, right? finish page equal to time dot perf. Question: why I am using perf counter instead of just time dot time? Type in chat. We can see like that if someone is really watching the stream or not. 1 2. So here finish epoch time dot perf counter. So now we have a print and we print, you know, what's so this item, I think, and then time duration. Let's say duration, okay? Just duration in seconds, okay? So duration will be what? Finish page minus start page. And we have this kind of thing, you know. I really appreciate this thing. You say like this, close. Ah, okay. Can I know the enumerate, right? Train.data loader. So we can prove it. Now correct, right? Now it's correct. Now then I out of Mahajan want me to edit for you. What to edit, guy? What? Hello, Mahajan. So and then we need to say and then length of train dataset. Train data loader. Enumerate data loader. So now data loader, right? Now we have data loader. If I call length of data loader enumerate right? I have an epoch, right? Enumerate data loader. Enumerate will call len, and so I can know len of data loader epoch. Oh, okay, we have 4 viewers, guys. Good. Your videos and rebrand your channel. we have not this one. Now we need to calculate the estimated time for the single epoch. It means this finished batch minus start batch. If we do like this, we get the speed, right? We get the speed. We get the speed. So if we get the speed, average speed for one iteration, one forward and backward pass, so we need to multiply by what? Length of train data loader, and then minus I. Here we have a typo. Train data loader. Average time equal to finish batch minus start batch. Okay, so now instead of this, average time. Okay, so here, do we need to say average time? What? Average time. Okay, epoch. Trainers item. Average time equal to 0. Average batch time no, we should increment, right? We should increment. So here average time is this one, right? Okay, we don't need, like, let's not make this perfect. Okay, it's working down. Okay, so now oh, no, not with push. Python train. What is this? We opened somewhere something and we didn't close it. One 181 epoch, correct. We forgot one thing. So we need to close these brackets. then remaining average time length of this. Okay, we need to close this. Length of this one minus I, and then this one. Now it should work. Now it should work. Mismatch network type and impact convolution output. Oh, is it because maybe device? Guys, for now let's do a CPU. Let's keep it in CPU. Let's keep it in CPU. Let's run it. It should work, I think. If it doesn't work, we need to fix. We will fix it. Okay, we have an error. Train data loader. Train data loader, train data loader, and here data loader. Okay. Let's check it. It is in seconds. Total loss is this one. It's huge. To reach in 22 seconds. Oh my god, to process one epoch we are spending 22 seconds. Oh, why is this loss is so huge? We have problem, we have a bug. No, it's something wrong. Something really wrong. Nice. And total loss. This is total loss, right? Each time we are updating it, right? One, two, three, four, five, right? We are updating. And step. Then why I is not increasing? I mean, like, why I is not increasing? Yes. This I, huh? Oh, So here I think what is the shape of this guy? We have another debugging session. Debug. We should debug. Empty shape. Huh? Empty shape.
вообще чего вернется?
Why shape is empty? Oh, empty shape. Shape is empty. Shape. Hmm? Yeah. Oh, problem.
Train momentum.
Hmm?
Train momentum.
Moment.
Hmm?
bug bor qayerdadir, bug.
GPT'ga bering, bug'ni top deb.
Enumerate ham ishlamagan ekan, mana qilyapman.
Ha?
Enumerate.
Nima ishlamaydi?
Mana bu I duplicate degan-ku. Batch I. Okay. Enumerate. Aka u shon chiqadi. String xalat beradi.
Ovoz chiqadi.
Konkret ovoz chiqadi.
Farqi bormi?
Farqi yo'q. We should eliminate this guy.